So yesterday we were doing tests with two samples, but they were related. It was matched pairs data. So we didn't actually test each of them independently. We looked at the difference between the two and ran our tests on the difference. Today we're talking about independent samples. So if I just want to run a test off two different sets of data, they may or may not have the same number of points. Maybe I want to compare Algebra 1 scores to ELA 1 scores. Okay, are there the same number of students in Algebra 1 and ELA 1? Probably not. But I could try to make some comparisons. In order to do that, we have to have some basic information from each set. Either I have to have both sets of raw data, which we would enter into the list on our calculator, or we need to know the mean, standard deviation, and number in each set. Since we're talking about the mean, both samples either have to be normal or both bigger than 30. So that's our criteria. We are looking at the two separately, so we have to consider that. We are going to stick with just the p-value approach, doing it on our calculator. I'm trying to eliminate all confusion, and we're kind of short on time, so I'm not doing the by hand. We're just sticking with one method and going with it. So it's very similar to what we have done, except we have two sets of data. So let's look at this one. A researcher wanted to know whether state quarters had a weight that was more than traditional quarters. He randomly selects 18 state quarters and 16 traditional quarters. As soon as I see that, is there any way it could be matched pairs?
No.
No. In order for this to be like dependent, where I would look at the difference, I would have to have somehow the sets would have to be linked. And that really wouldn't be possible here because it's not like there's a Missouri state quarter and a Missouri traditional quarter to link up. Test the claim that state quarters have a mean weight that is more than traditional quarters at 0.05 level. Assume the data is normal. One thing I have noticed in looking at the Chapter 10 homework that you turned in, some of you are missing a key step. You're telling me reject or fail to reject, but you never wrote down a hypothesis. You have to write down your hypothesis every time. So every single problem, you should have a null and an alternative hypothesis. You can't reject something you never wrote down to start with. So here, we are talking, yesterday we were looking at the difference between the two. I can't do the difference here. I'm testing that state quarters have a mean that is more. So this is like group 1, this is group 2. The null is just that they are the same so that the means are equal to each other. So when it's matched pairs, the null is always the mean equals 0, the mean of the difference. Here, because I can't look at the difference, I just have to do the mean of the first is equal to the mean of the second. If I'm testing if state quarters weigh more, what would my alternative be? Greater than. I know it's normal, so I don't have to worry about my other criteria. We're good there. So now we are going to enter our data. So I want you to go to your calculator, enter all the state quarters in L1 and the traditional quarters in L2. Our data entered. We can't do the difference. We don't even have the same number of points. They're not related. So now we are going to go to Stat, Tests, and we are used to doing a t-test, but here I have two different samples. So you are going to go to number 4, a 2-sample t-test. So yesterday we were doing number 2 because we were just doing the difference. Now we're doing the 2 separately, so 2-sample t-test. You have to base it off data or stats. If you have stats, a lot of your questions on the homework will have that because it's really time consuming to enter all this. You just have to enter the mean, standard deviation, the number for your different sets. Okay, so you should have it, it'll say like mean of 1, standard deviation of 1, number of set 1. Mean of set 2, standard deviation set 2, number of set 2. Here though, we have data. So it should say list 1 is L1 and list 2 is L2. Frequency should be at 1. we were testing greater than. Pooled, don't worry about that, it just needs to be set on no, we're not going to change that. And then calculate. Okay, so what I like for you to write down after this is your T and your P. So your T is 2.5367. Do you know this is the 67th day of school?
Yeah.
Okay, just checking. And our P is 0.0086. Right, did everybody get that? Okay. So the bare minimum, what I expect on these, how I'm going to have it set up on the test, you'll have to write the null and alternative hypothesis. You have to verify your criteria, unless I tell you it's normal. Then what I'm going to do is on the test, I'm going to have like stat, test, and a blank. So you'll have to tell me which test you're doing. And then I'll say, tell me the T and the P. Okay, so on the test, I'll have it kind of a fill in the blank so you know and you're showing me everything you need. And then you need a conclusion, which is either reject or fail to reject. Our alpha was 0.05. P is less than alpha, so what does that mean? So our P is less than alpha, we reject. If I asked you to write a sentence explaining what that means, would be there is sufficient evidence to conclude that the state quarters weigh more than traditional quarters. All right. Any questions on that? We can also use confidence intervals to test our hypotheses. So let's look at one of those. If I asked for a 95% confidence interval for the difference between the weights. So again, you have to have your data entered, which we already do. This just goes with our previous example. Then you would still, technically, if I'm asking you to test a hypothesis, make sure you have the hypothesis written. I didn't ask you to do that here. I just asked you to do the confidence interval. So you are going to go to stat, test, and I think it might be 0, 2 sample T interval. So normally we just do a T interval because I have 2, we're doing a 2 sample T interval. Again, we have all of our stuff entered in data. So we just need to change our confidence level. We needed 95%.
What does pooled mean again?
Just always set it at no. We aren't doing any pooled data. Whoops. And if we go down to calculate, we should get our what you guys got. If you were testing a hypothesis, remember, this was what we had written down. Okay, it's a little less obvious for testing the hypothesis here, but the null is that they are equal. If they're equal, there wouldn't be any difference between their means. So it would be like a 0 in the interval. Since 0 isn't in the interval, that would lead us to reject. So this does confirm what we already said. Okay. Questions on that? I want to switch over to these slides. I think I have extras of both chapters 10 and 11, so I want to work through some, if not all, of these. So, first one. The standard deviation of SAT scores on the reading portion is 112. A teacher believes due to a new class in her school, the standard deviation has decreased. Write the null and alternative hypothesis. So, what is my null hypothesis?
Standard deviation is 112.
So my alternative is, what parameter is being tested? In this case, it's just standard deviation. You guys do have these slides, right? Should be in between chapter 10 and 11, I think. Would this be left, right, or two-tailed? Less than is to the left. Okay, suppose the null is not rejected. Write a sentence stating the conclusion. Does that mean I proved the null hypothesis was true? No, it just means there was not enough evidence to conclude it had decreased. Okay. If the standard deviation is actually 100, what type of error has occurred? So, remember, we didn't reject it. So we concluded the null was true, but it wasn't. Do you remember what type of error? Mhm. Remember, I told you type 1 was when you conclude H1. Type 2 was H0. So that was type 2 error. All right, these slides match up very closely with the handouts that I'm leaving you tomorrow. So if you get confused, look back, it will kind of line up. Like question number 1 is very similar to this slide on here. All right, we are not going to do any by hand. We're just going to look at this. So if I asked you to test this hypothesis, we need to verify criteria on every problem. Remember when we're dealing with the p's, that's the n times p times 1 minus p greater than 10. So we have 200 times 0.3 times 1 minus 0.3. That is greater than 10, so we're okay. So now, we have to figure out what test to go to. Okay, if the null and alternative weren't written, you would have to do that. It is given here. We aren't talking about a mean, this is a proportion. So do you remember what test we did? Close, that's the confidence interval. It's number 5, the one proportion Z test. So if you go stat test number 5, your P sub 0 is just the P of the null, so that's the 0.3. The X I told you was 75. The N we were told was 200. We're testing greater than. The work that I would expect you to write down, make sure you have criteria, have to have hypotheses. Then I want you to tell me your Z and your P. So we get a Z of 2.3146, our P 0.0103, and then our conclusion. Would we reject or fail to reject? Alpha was 0.05.
Reject.
Yeah, P is less than alpha, so we reject. So highlighted things, bare minimum of what you have on every problem. Okay. Let's try another one. A study found the mean ATM withdrawal to be $67. A review of 40 withdrawals shows the mean is $73 at a new machine with a standard deviation of 13. Do people withdraw more money from the new machine? So, what do I need first?
Criteria.
Criteria,
Hypothesis.
the null and alternative, good. Okay, my criteria. This time we are talking about a mean. What's the criteria with mean?
N's greater than 30.
Good. And this one is, so we're good. The null, we're talking about the mean. So the null is always equal to, so the mean is 73. What's my alternative? Oh wait, not 73, 60. What's our alternative? Mm-hmm. Okay. So then we can do all this on the calculator. Stat, test. I am talking about a mean this time. That's the interval that goes with it. 2. 8 is the confidence interval for it. And A is the confidence interval for the proportions. So if we go stat test number 2, the mean of the null was 67. X bar, the mean of our sample.
70.
The standard deviation of our sample.
13.
My N.
40.
And we are testing greater than. So if we calculate that, I want you to write down the T and your P. So the T is 2.92. You can give me more decimals if you want. P 0.0029. And then you have to tell me your conclusion. Here my P is less than alpha, so what does that mean? Again, things that I'm looking for points. Do you have a criteria, hypotheses, T and P? Tell me if you reject or fail to reject. Is this coming back from before Thanksgiving? It's been a while. Let's do one more. In 2001, 38% of adults with children under 18 reported their family ate dinner together 7 nights a week. In a recent poll, 403 of 1,122 adults with children under 18 reported their family ate dinner together 7 nights a week. had the proportion decreased. So, what do I need to do first? All right, we are talking about percent of proportion. So my null is that p is equal to 0.38. So my criteria, that's the n times p times 1 minus p. So my n, 1122, p is 0.38. Definitely bigger than 10, so we're good for the criteria. What's my alternative?
P is less than 48.
So I'm talking about proportion. What test is that? 5. And if you forget, just look at them. You'll know when you have the right test because you'll have the information. If I pick the wrong one, it's going to ask me for stuff not given in my problem. The p of the null is 0.38. My x was 403. My n, 1122. And you're testing Leslie. So then I would want you to write down the z and the p. And then your conclusion. What's my conclusion here?
Failed to reject.
P is greater than alpha, so fail to reject. We don't have enough evidence to conclude that it has decreased. That's our chapter 10 review. I have chapter 11 review questions as well if you guys want to do them. Do we want to do the problems like the last couple days? Okay. Let's pause. Let's work on that homework packet. If we start having trouble with that, then we might do some of these chapter 11 problems.